beer today is Great Plains Brown Ale from Two Wolves Brewing. Interesting, a portion of the profits from Two Wolves beer sold across the country will go to support the protection of wolf habitats in Canada. Tasting notes suggest that it has aromas of roasted malt, cocoa, and caramel. So today I'm going to take a little bit closer look at these little tablets here. So these are a fairly simple little thing. You can draw on them with the supplied stylus or with a finger or a fingernail or whatever you want, and then just push the erase button and it erases the screen. That's all it does. It's just that simple for little quick notes and stuff. I guess the kids could draw on it or whatever. And I got a couple of them just because they were cheap. This one doesn't seem to work. You can draw on it, but you can't erase it. My guess is the battery in it is probably dead, assuming that the battery is only used to erase it. I don't know that for a fact, but I guess that will be the first thing to check, is to pop that battery out and find out. Oh, okay. See if this dental pick from my collection will pull that battery out. That's annoying. CR1220. That's not the most common battery, but I suppose I could probably find some somewhere. Let's just see if there is any voltage in it at all. It reads as a resistance. It should have 3 volts in it or thereabouts. Okay. So that's probably what it is. Let's grab a battery out of this one and see if that'll tell us anything. I'm assuming that one's working. Yeah, 2.9 volts. Okay. So let's put that into the blue one and see what happens. Oh, it's going to be a pain in the ass because I won't be able to get it out. So, does it work? Yes, it does. Okay. So that battery is just toast. I'll just put it out of the way. But in the meantime, now that we know that it isn't this one, although this one, the battery compartment is a pain in the ass to get the battery out of. So I think I'll put that back together with the black one, and I will do the tear down on the blue one. Maybe I'll be able to get it back together. I don't know. We shall see in due course. So now then, how do we get into this thing? Looks like it's seam welded around there, but it also looks like that bezel is just a sticker on there. So let's grab something in the Spudger collection. See if I can. Oh, that was easy to get under. Okay. Oh wow, there's like nothing to it. That's just a sticker on there. Okay. Oh, this might be faster than I thought. What are we seeing back there? Oh, there is a little circuit board or something down at the bottom there that has only 2 connections. Wow. Okay. Oh, and I've damaged that. Is that really all there is to it? Okay, let's pull that little circuit board out then. This is going to be faster than I thought. Okay, so you can get underneath there. Ah, so there is more than just throwing voltage at the thing happening. So it seems like the battery connects through an inductor. And some capacitors, a couple of transistor devices there, a couple more there. Several transistor type devices, 2, 4, 6 of them, I think, all told. And this little guy here, I wonder what that IC is. Looks like we are going to be wondering forever because there's nothing on that little chip. Damn it, I hate when they do that. I wonder if there's just puts a high voltage on there, or if there's a waveform that it puts on there. Maybe we can resurrect this thing after all. The sale description just calls that an LCD, and that may be what it is. So maybe just the flexing has done the same thing as deforming it like that to discolor it. So maybe we can revive this thing. Although it's not looking good. We shall see. Okay, let's see if that does anything. I guess I gotta put power on it. Okay, so I got 3 volts on the power supply here. But that connected in place of the battery. I've got just some short wires there. So let's see what happens when we push the button. Oh, hey, that recovered. So even when you flex it like that, except for this little damaged bit down in the corner here, it does the thing. Cool. Now then, obviously, that signal on there is something other than the 3 volts that's coming out of the battery. But what? So let's try this. Now when I push the button, looks like there's some relatively low frequency square waves happening. I'm going to see if I can get some markers on the screen, which could be difficult with this not being a storage scope, but we'll give it the best shot here. It looks like it's about 20 volts or 21 volts. And what is that frequency looking like? It's triggering from there. Is that hitting about there? About 20 hertz or so. So 20 volts at 20 hertz. That's the control voltage. Okay. Okay, much reverse engineering has happened with the help of my magnifying glass and my optovisor, because this thing is tiny. So here is the whole circuit laid out in, I don't know, what do you want to call this, chicken scratch vision. The unnamed chip remains unnamed, but I figured out where the connections go to it. So let's start with the basics. Power comes into pin 1 from the battery. Ground is pin 8 back to the battery. Pin 2 is the switch. That's the easy part. The rest of it's not that hard anyway. We've got 2 identical little driver circuits going to the LCD. This one goes to the pin marked positive. This one goes to the pin marked LCD positive 1. I don't know, it's an AC circuit, I guess. So these 2 sections are identical. I'll just go through one of them. Pin 3 and pin 7 drives them. Pin 3 drives the base of this NPN transistor through a 33K resistor. On the other side, we have this PNP. Its base through this 470K comes from the collector of the other side, and this one down here has the same thing going on. The emitter of this PNP transistor comes from over here, this little circuit over here, which I'll look at in a second. And I'm guessing that the chip here is turning these 2 on alternating, maybe? I'm not sure. I didn't dive too deep into it. It's pretty tiny to get the scope probes in there. So this looks to me like it's a little voltage boost circuit. Pin 5 is probably oscillating it. The inductor and capacitor creating a boosted voltage every time this gets shorted and brought high again, isolated. That is going out through Q2, which is an odd configuration because its emitter isn't connected to anything. So I'm guessing it's just being used as a diode. Why wouldn't they put a diode in there rather than just another transistor? Probably just to keep the BOM cost down, because they've got, they've already got that NPN transistor here, here, and here. So why put a different part in there? I don't know. That's my guess anyway. So that goes out to the emitters of both this one and this one. So that'll be the, what did we measure? 20-ish volts. And then this guy will be pulsing on and off to create the square wave with, what was that? Only a handful of pulses on the square wave. And that signal somehow causes this LCD to erase when you push the button. I don't know what's going on inside this little panel. I assume that is how you control what's going on with an LCD. I'm not sure why physically deforming the thing is what causes it to make a mark, but it is an interesting little thing nonetheless. And I'm glad I spent the time tearing it apart. So I hope you found that slightly illuminating. I know my curiosity has certainly been satisfied with this, and I'm glad that it mostly still works after I tore it apart. even though the only real problem with it was that dead battery. Not sure if I'm going to try and put this one back together or if I'm just going to keep using this one. We'll see. Anyway, that was fun. Questions, comments down below as usual. Thanks for watching. I'll talk to you later.